Good afternoon, everybody, and welcome to our series of lectures on ethical implication of AI. My name is Roberto Ziccari. I'm quite happy to introduce you. The guest speaker of today is Dr. Michelle Hind, distinguished research staff member from IBM Research in the Artificial Intelligence Department. The title of his talk is Increasing Trust in AI. Mike, the floor is on you.
Thank you very much, and it's a pleasure. Thank you for everyone for attending. Just a little bit about myself. One of the topics you'll hear shortly is about bias, and so we all have biases, so it's good to know where I'm coming from. I'm a PhD back in a long time ago in the 1990s. And my background started to be in programming languages, system software, software engineering, program analysis, things like that. And then about 3 years ago, I got very interested in the problem of initially explainability, and then branched out to interested in bias and fairness and transparency. And you'll hear all about those topics coming up. But I just want to say what I don't know. I'm not a social scientist. I'm not a public policy person or philosopher. I talk to a lot of those people, and I'm learning a lot, and I'm sure there's some of those folks in the audience, and I look forward to learning from you, from your questions, and maybe future interactions. Okay, so first, just a little bit about where I live during the day, and that's in IBM Research, and in particular, I'm part of an organization called Trusted AI, or Foundations of Trusted AI. And we're looking at this topic that I'll be talking about shortly, and that is, AI has a lot of advantages, but there's a lot of concerns, particularly when citizens' rights or basic rights may be at issue. And what you'll see is, well, we've done a good amount of work of publishing papers, scientific papers, but also releasing open source toolkits as a way of educating folks on what the underlying technology is, and also opening up avenues for communication between different disciplines to help bridge the gap into solving these important problems. We also work closely with our product division, as you would expect. And in particular, this is a picture here where some of the people are researchers and some of the people are product people. I'll leave it as an exercise to figure out who do you think is who. But we've been working with them. In particular, IBM has a product on the market called OpenScale that does some of the functionality we're talking here. I'm not going to say anything else about that, but just in case anyone happens to be interested in such things. We also work very actively in a whole bunch of other spaces, not just, say, the scientific community. The topics we're going to be talking about, and you've been seeing in this course, are not just technical topics that hopefully can help people, but they're actually deep topics that society has a very, very important stake at the table to help shape, define, regulate, whatever it may be. So it's not sufficient to be just focusing on the scientific community or even the open source community. It's important to be plugged into all these kinds of efforts. And here's just a subset of some of the things that we're involved in terms of, I'm sure everyone knows about the EU Higher Level Expert Group. There's the Partnership on AI, which is an organization that came together about, I think, 2 or 3 years ago. IBM was one of the 5 founding partners. And now there's on the order of around 100 different organizations, companies, but also nonprofits, universities, and so on. Trying to work together to basically try to solve problems, not just from a particular university or company point of view, but hopefully collaboratively. There's work with NIST, which is a standards body in the United States, and so on. You can see open source and so on. So what I first want to do is because I realize there's a lot of people interested in this and they come from different backgrounds. I just want to go take a few slides to say, how did we get here? And make sure we're all on the same page. I have, some assumptions, and so just to go through that. So as I'm sure it's been covered, I think somewhere, You know, there's these terms: artificial intelligence, machine learning, deep learning. Often people use them interchangeably, which is not really accurate. Artificial intelligence is a very broad term. It goes back to the 1950s. It basically says, is there a way of having a system that shows some kind of intelligence that we would associate with normally with humans, right? Build some kind of system. And there's sort of two big ways of doing that. One is machine learning. Another way is rule-based systems, where there's a belief that humans have rules and maybe instinct or intuition. And if we could codify those rules, then we would have a system that would be able to exhibit artificial intelligence. Machine learning takes a different approach. Machine learning focuses on, well, it'd be nice if we don't have to explicitly program those rules, but if the system could actually learn those rules by giving a whole bunch of examples, and then have the system infer those rules. And we'll talk more about that in a second. And then deep learning is a form of machine learning where you're making what's called a neural net, a very simple idea, and you have many deep layers. And I'll show an example of that in a second. So, and in fact, here's the example. Not meant to be exhaustive, just to give you an idea of what we're talking about here. So let's say the problem we have is we have a bunch of images here on the left. And what we want to do is build a system that prints out basically what the image is. Is it a cat, a dog, a horse, a monkey, etc.? And generally what happens is you build these neurons, which are supposed to be a simplification of how the brain works. And they're basically shooting out positives, shooting out a positive or a negative view in terms of what it's trying to recognize. And so, oops, sorry. So the idea here is initially, these are all set to be a random setting. The horse is fed in. The horse is really just a sequence of pixels with values. It's fed into this neural network. And then the first prediction that comes out is going to be wrong, because these are just random settings of these neurons. But then there's a very important operation called backpropagation, which is a way of basically telling the network that, hey, you're wrong, and we think we know who's the main culprit in the network that is contributing to the wrong answer. So it's a way, I'm sorry, it's a way of basically having the network sort of fix itself. I'm speaking very high level here. Why is that happening? Okay, geez. Okay, I think I got a timer on that. I apologize. So basically, the idea is you keep doing this forward propagation and back propagation. All right, I'm not sure why that's happening. Just, I think there's a timer on that. So I'll go back to the screen show in a second, but just so that we can see this, you're basically setting weights on these neurons. You get a wrong answer, and then you go back and you kind of fix the weights. You do it again. And if you do this process a real lot of times, this iterative process a lot of times, you can eventually get networks that can recognize that this is this actually is a horse, okay? The interesting thing here is that, well, is that enough? I mean, I've recognized that this sequence of pixels is a horse, and maybe if I train it enough, I'll recognize this one is a horse too, and this one is a horse. But it's not clear it's learning what a horse really is. It's learning about patterns that for this set of images actually works reasonably well. But when it sees a different image of a horse, it's not clear if it's generalized to know what horses are. And there's a famous example of this where there was, I think it was a polar bear, some other animal, where they trained a neural net and it came out to be pretty accurate. And then it turned out that what was actually seeing in the image was the background of the snow. It learned that when you saw snow, the image was likely to be, I think it was a polar bear. And it wasn't necessarily focusing on the polar bear itself, but was focusing on other attributes. And so that's the thing that we have to be careful about here is deep learning has been very effective. Many of the advances that we've gotten and we associate with AI, and the reason this course exists is because of advances in deep learning. But what they're looking at is in this case, images, or it could be speech or audio file, and it's learning whatever it learns, whatever patterns are there to signify the right answer. And it's not necessarily doing the same thing as a human does, which could be good or it could be bad. And I'll talk a little bit more about that when we get into explainability. All right, let me try to go back here. All right. So I said in the two slides ago that these ideas are not new. They've been around for, in some cases, decades. Why did suddenly AI, in particular deep learning, explode and be available on our phones when we're doing voice assistant, when we're doing going to an online shopping, and we have recommendations of other things to buy, and so on. And there's sort of three reasons for that. One, for this technique to work, you need a lot of examples. And because of how things have evolved with the internet and social networking, we have a lot more data. On the left, you can see some examples of data. We have tons and tons of videos, and then other places we have lots of information. So we have a lot of data. The process I mentioned as well requires a lot of compute. You're iterating back and forth many, many times. So to train a system to be able to recognize those images requires a lot of computational power. And luckily we do have that. And it turns out GPUs are incredibly valuable. They weren't built for this problem, but they actually work very well for this problem. And so it's just advancing in raw computing power. And then also algorithms, which I'm not going to go into detail, but just new ways of doing those neural networks and tweaks like that the AI folks have invented. So these are three things all converged. And you can see on the right is just one of many, many benchmarks where the problem here is a big data set called ImageNet. And how many errors do you have when you try to classify the images? And you can see these are the best algorithms over the years. So lower is better. This is measuring error. And you can see in 2010, it was pretty bad, about a little more than a fourth were errors, and then so on. And then finally in 2015, it got to be less than 5%, which is better than the average human. So that was a breakthrough, and I guess I haven't updated this slide since then, so sorry for that. And then just wrapping up here on this little introductory section, why would an enterprise use AI, right? So this is an important question because I work with a lot of customers, and they say, I hear a lot about this AI stuff, and I think I want to use it. And it's important for them to understand what are they trying to do, right? And so this slide breaks down sort of three reasons why anyone, I say an enterprise here, anyone might want to use AI, excluding scientific, curiosity. One reason is you have some existing process and you want to make it better, more accurate, right? So we just saw an example of that with ImageNet recognizing images. You want to make it more accurate than what you had before, either as a system or as a human. A better example would be if you're trying to detect cancer in images, and you can do a better job, maybe a quicker job or a more scalable job than if you had a specialist doing that. And there are examples of doing that. Another popular reason is you want to reduce the cost of some existing process. So both first and second reasons are you have some existing process and you're trying to either make it more accurate or you're trying to reduce the cost, right? So maybe it's you've got a situation where you have customer care or customer support, you have a product and people are calling to get help with the product. If you can have a system that gives them an answer right away, such as on a weekend or late at night, when maybe there's not a worker available, that's going to make the customers happier. Another example is the sports highlights, which I'll talk about a little more in detail. Is there's lots of sporting events and a lot of people care about that. And often networks try to make highlights of what happened. So you can imagine, a very long, let's say, golf tournament that goes 4 days, or a cricket match that goes a long time, and you want to get the 1-minute highlight reel. That's a very labor-intensive task where a person has to watch all that action and then figure out what's worthy of a highlight. There's work on having an AI system try to figure out what are their highlights. And do that in a more automated way. So that would dramatically reduce the cost and allow people to see the highlights, almost in real time. And then the third case is where you want to do something that's not being done now. right? Because probably it was too ineffective, or we couldn't do it accurately or timely. There's a lot of examples of that. You know, one is, I think we use all the time when we go to our search engine and we start typing in a search thing, it auto completes for us. It tells you, are you looking for that? And it helps you do that. And that didn't exist. There wasn't a person who was watching you type in the past and then would make suggestions really quickly. It just didn't exist. Similarly, is, you know, recommendation systems in general. If you go to a streaming company and you order some movie, there'll be others that will pop up and say, hey, you know, I think you might like this. Or even online shopping is a similar idea. So the moral of this slide is to say that it's important for a company to think about this. What are they trying to do? And then to measure whatever it may be. If you're trying to measure something being more accurate, then measure accuracy. If you're trying to reduce cost, you know, then do that. If it's something new, you know, then you might need to think a little harder about what the metric should be. I was with a company that initially was trying to reduce cost, and then they discovered, at least they thought, that they were increasing their accuracy. And so the goal of the system kind of transformed over time. Okay, and then finally, before we get into the ethics part, I just want to give some more examples of where AI, you know, could be used, and this is clearly not exhaustive. One of them is in compliance. So there's certainly, you know, regulations and laws that are on the book that enterprises need to abide by. And it's always a challenge when they see, you know, here are the regulations written down somewhere, and then here is my current process. And there's the concern is, can I somehow have an AI system help me understand my current process to see if it is compliant? So it's basically, you know, maybe two textual documents, and can I understand if they're, you know, if I'm actually matching that or not? Could AI assist in that case? Another example is in marketing and businesses in particular. Companies certainly focus on their products, but also focus on what other companies are doing. And often other companies have public information about what they're doing, right? So either they've made an acquisition or they've done something maybe with their stock or invested in research or whatever it may be. But that's, you know, that information is distributed all over the place. And so could you have AI actually help you mine all that information and give you some kind of summary of what, you know, what a company might be doing, a competitor might be doing? Customer care, we talked about already. There's a huge demand for that. We've probably interacted maybe sometimes positively, sometimes negatively with bots that try to help us. Healthcare is very important, particularly in the current climate, of course, but in general, looking at images and scanning things, in this particular case for breast cancer, but there's many other examples of that. Media, I mentioned sports highlights already. And then the last three are all related, somewhat related. It's looking at, you know, you have infrastructure, and the one on the bottom here, visual inspection. That one's basically saying, I've got some infrastructure I really can't get access to easily. So maybe I have something like a drone fly up to see this tower, take some pictures, and then I can decide if that is, if there are signs there that this may be a tower that may be in need of repair. Somewhat similar but different domain is looking at crops and trying to figure out, you know, what the yield might be, again, with some kind of technology from the sky, either a satellite or a drone. And then again, somewhat similar but a different domain is looking at components and trying to figure out, you know, in a smaller sense, whether or not they are might malfunction. Okay, let me just pause for a second. I saw some questions popping up, and maybe Roberto, if there's any you think are worth addressing, I can do that now.
Yes, thank you, Mike. A couple of questions here. I think one you asked, you answered already, is from Magnus. That said, how about a creative value proposition, for example, within entertainment? I think you mentioned something, but do you want to say something about that?
Yeah, without a doubt, there's examples of that. I have a colleague here at IBM Research who took a movie and had an AI system try to come up with a trailer. It's kind of like a highlight kind of thing, but only for a movie. And they had discovered, for example, what makes good trailers, right? And it turns out, some tension, some action, some, I guess, some tenderness. And it was for a movie called, I think it was Morgan was the name of it. It was maybe like 3 or 4 years ago. And it was the actual trailer that the company used on TV and ads and so on. So without a doubt, yeah, creativity. There's a group certainly in research, I'm sure, around the world, and IBM research, that are looking at using AI to either be creative or to aid a creative person to do things.
Yeah, thank you, Mike. There's a question for me, actually, that I would like to ask you. In the list of your value proposition of AI, you did not include improving social responsibility. Is that because people don't care, or because you don't think it's a priority?
So it's clearly a priority. Yeah. So I guess that list was things that usually enterprisers are thinking about, and it's a little bit dated, right? So I think now you will see, a lot more people thinking about that. And actually the rest of the talk is talking about, I do care about social responsibility, so what can I do? So it may be a little bit confusing. What I wanted to do was sort of quantify why people are attracted to AI. And when you talk about a business, it's usually because they want to be either more effective or we want to reduce costs. Those are sort of the bread and butter things. But your point is a good one, is that companies also have a social responsibility. And what can they do there? And as I'd say, there's two parts to that. One part says, don't do any harm. Right? If I'm going to use AI, make sure I do it in a responsible way. And that's what the rest of the talk is about. The other is, I think what you just were asking about is, can I actually forget about AI doing harm or not? Can I just use AI for the sole purpose of being more socially responsible? And I think that's a great idea. In fact, I'm not going to talk about it, but there's a program at IBM called AI for Social Good, where they've worked with a lot of NGOs to basically have interns come in, and they do all kinds of things. And there's like a website on that as well. So yes, without a doubt, that's a very good point. And I probably should update the slides. Thank you.
Thank you, Mike. Maybe the last question is actually related to this one here. Have you seen AI being used for discovering unfair and discriminatory processes and systems? So rather than checking if the AI is fair or not, have you seen the AI as a tool for checking if the outside world is fair?
I'm guessing that exists, but I can't think of an example that comes to my mind. But I gotta believe it exists, because there's many people working in this space who care a lot about bias and social justice and so on. So I would think that it definitely exists, but I can't give an example off the top of my head.
Thank you. Would you like to continue so that we can take question in the middle?
Yes, yep. And I will be pausing. You'll see shortly that the talk is focused on basically 4 components, and I'll pause after each of those components. These aren't the 4 coming up, but the next slide will show you that. So there'll be more opportunities to ask questions on those components. So what I said so far was talking about AI, talking a little bit about how it works and why people might be attracted to it. And now we're going to talk about, the warts, I guess I would say, on AI, or some of the concerns people may have. But first, I want to motivate that by saying that, yes, AI is already part of our lives. We use facial recognition if we've got an Apple phone, probably. We use it when we're doing searches, where we're doing online streaming or online purchasing. Social media certainly uses it when they show us what kind of ads or what kind of posts they want to see in your feed. So it's already happening in those cases. Where I think a lot of concern has come up is now AI being used in what are often called as high-stake decision-making use scenarios. And here's just a sampling of some of them. So one example would be, I'm going to use machine learning to decide whether or not you should get approved for your car loan or your mortgage, whatever it may be, right? So for credit, based on what your answers are to the application and based on what I've seen in the past, are good credit cases and bad credit cases. Another example would be for employment, either for hiring someone. You can imagine, and I've heard several customers talk about the following scenario. I have one job opening, I get 10,000 resumes. I don't have a person to look through 10,000 resumes. Could I have a system show me the top, let's say 100 candidates for the one position, and then I'll have a person look at those top 100, right? Seems like on the surface, a reasonable thing to do, but in reality, it can be an issue if it's not done the right way. Admission into schools, similar idea, right? Where I've got many applicants. Maybe the current process is not thorough enough. I have to hire many different admissions counselors, and maybe they're not consistent. They have their own biases. Could I have a more standardized way of evaluating applicants? But of course, we don't want things to go wrong with that, right? Sentencing in criminal justice system, it's sentencing, it's parole, and so on. I'll talk examples of that. Similar kind of thing. Judges may vary. Maybe and there's been studies on this, that depending on the time of day, maybe you may get a more lenient sentencing or not. The question here is, could I have an AI system that maybe is more consistent, but hopefully not more biased? So I'm not saying whether these ideas are good or bad. I think on the surface, you could see an upside, but you also could see, wait a minute, there's some serious concerns here as well. And so since people are investigating these ideas, this has raised a lot of concerns to say, let's make sure if we do this, that it's done in a fair way. It's concerns from, I would say, AI folks, concerns from social justice folks, certainly, and then also governments and regulatory bodies trying to say, well, wait a minute, maybe we should have some laws on what you can do and what you can't do. And I'll talk more about that as we go. So here's sort of the table of contents slide. At IBM Research, we think of sort of 4 components when we're talking about trusted AI, right? We think of fairness. Is the system fair? Can we measure that? Is it explainable? Can we understand why someone was denied credit? Is it robust to adversarial attacks, which means it's possible for someone to come in and to trick the AI system to learn where its boundaries are? And is the system robust enough? And then the last pillar is governance or transparency, and I'll talk about all 4 of these. I know 2 weeks ago, a colleague of mine from IBM in Europe gave a talk and talked about toolkits and tools for this. And he showed a similar slide with the 4 different categories here. So I'm not gonna go in, and particularly he spent a lot on the 3rd one, robustness. So I'm just gonna say a few things there, and his slides are available, videos available, you can see it. And the parts I know we also covered a bit on fairness and explainability. I won't cover the same information. I'll have a different take. And I want to spend a decent amount of time on the last one, which is this concept that we call fact sheets. Okay, so after each of these, I'll pause. I'll just mention that what we've done at IBM Research is we've seen the scientific community has been publishing papers in these fields. These fields themselves have their own conferences and venues, and there's a large number of researchers working in those fields. Plus, society cares about these problems. But what we discovered is a big gap between the two, right? That the technical papers typically written by machine learning experts aren't necessarily accessible or usable by people, let's say, are sociologists or philosophers or so on. So we're trying to bridge the gap by coming up with sort of 2 things. I'll tell you more in a second. Each case, sort of a website that has a lot of educational information, and then open source code that someone can use to measure or mitigate some of the issues in these 3 pillars. Okay, so now I'm going to jump into the fairness or bias category. So I'm going to go through a few examples here, and the idea is the examples are structured pretty similar. On the top, we'll describe what the idea was for this machine learning system. Then I'll show how it went bad. And then usually on the bottom, there'll be an apology from a spokesperson from the company, okay? And I'll say up front, I'm not trying to pick on any companies here. This is to just demonstrate that the idea on the surface is a good idea, but if you're not careful, then bad things can happen, right? So this one was a sentiment analysis, and the idea here is there's text that's written, and I want to have a system that can look at the text and say whether it's positive or negative, a sentiment, right? So you can imagine if I have a product and someone is doing reviews of my product, I would like to see if they're saying positive things or negative things. And in particular, if they're negative, I'd like to have someone go and post something to reply to that saying, you know, we're sorry, we'll try to do better, or whatever it may be. And you see this all the time with reviews. So in this particular case, there was analysis where they took statements that were neutral, that should be neutral, that should come out with a value of 0. And in this particular case, this is data, this is back in 2017. I'm sure the system is much better now. It came out with cases where, you know, it should have been 0 and it was not 0. And this just showed some bias in the algorithm for sentiment. Here's another one, again, another good idea, I believe, where I've got a whole bunch of images and I want to be able to have a tag for those images. I put them in a category, you know, like this one here is a bunch of cars. This is a bikes, right? And the reason you want to do this is search works really, really well, but search on images, you know, doesn't really exist, at least didn't really exist. So if I could turn the search on images problem into a search on text problem by having text with each image, then I can leverage existing technology for searching on text. And then it turned out that it mischaracterized a particular image, and that was not good. Here's an example of a system that did not go into production, but it's the scenario I mentioned earlier, where there was a whole bunch of applications, and there was a tool that was trying to go through those applications to save time and be more consistent. And what they found out in development was that it was looking at, that it seemed to be penalizing any resume that had the word women on it, right? And so what happened, and this illustrates an important problem in this space, is that in order to train these systems, you have to give it data, you have to give it examples. And in this situation, it was examples of people that the company hired previously, who was hired and who wasn't, right? And then the system learns whatever pattern that's in the data. In this particular case, it seemed to have learned that it was less likely for a woman to be hired, it seems, from the data. And then finally, one that was a bit more public was this chatbot. And the idea here was, could we build a chatbot that interacts with people and kind of speaks their lingo, right? So speaks the language to make them more engaging, right? And so the idea was, you know, to read what their people are saying to the chatbot, digest it, and try to speak that similar kind of way, not language literally, but sort of a style of language. In this particular case, less than 24 hours, some, you know, I will call them adversaries, were trying to trick the system to be basically to say bad things. And sure enough, that happened. So it's an example of an adversary. And the company had to pull the chatbot off in less than 24 hours and basically shelve the project. And so this illustrates that when you're building an AI system, you want to be fair in general to well-meaning individuals, but you also have to realize people who are going to try to come and sort of game the system, right? If you're trying to figure out who's going to, you know, get employment or credit, there may be people who won't necessarily abide by the rules, but if they can understand where the weak spots of the system are, they may, you know, may exploit that, and it makes it a little more challenging. So there's many of these examples. Here's you know, 9 of them. This is probably the oldest one, is maybe a year or 2 ago. I'm sure there's actually there are new ones. I'll show you one in a second. And they're all over the space here. Lots of press, and a lot of companies see this and get very, very worried, rightfully so. These are very bad, you know, situations. and they're trying to say, well, what can I do? Do I just give up and don't use AI at all, or is there something I can do? And a more recent example, this was at the end of last year. The scenario here was Apple was coming out with some kind of credit card. They were working with Goldman Sachs on this. And there was a husband and wife who had the same credit history. They basically had joint accounts. And they discovered that they both approved, and that the husband's limit was, in this case, 20 times more than the wife one, even though they had the same basic information. So it seemed to suggest that there was some kind of bias going on in the algorithm. That was very public, of course, and not a good thing for the companies. So finally, here's an example that I know was talked about by Roman 2 weeks ago, but I just want to make a different point on it. This was one of an existing system. It's in the criminal justice system, and the idea is someone's coming up, someone's been arrested, and you need to decide whether or not to let them out on bail. And usually a judge, there's a form that the person fills out, or gets filled out for them, with various questions such as, their prior arrests, I guess, do they have a job, and things like that. And then there's about, I think, over 100 questions there. The judge takes the information, and the judge makes a decision whether they should be out on bail, and if so, how much. Then there's a piece of software, AI software, that's been around for probably about a decade or so, that is looks at these answers and gives a number, a prediction, basically, that's the likelihood of recidivism, which means likelihood of being arrested again if you let the person out on bail. And ProPublica did an analysis of this. It was very, very challenging. I really urge anyone to read the article. It's challenging to do because the program, of course, is not publicly available, and the data wasn't necessarily available. But they got a good proxy for this. And what they discovered was that the algorithm was more likely. They discovered sort of two things. One was the prediction accuracy was the same for blacks and whites. They were looking specifically at that. They thought there'd be discrimination. But when the algorithm was wrong, it was twice as likely to be wrong in the bad way for blacks than whites. And the bad way would be, you can't go out on bail because we think you're a risk. And this is an example. The reason I point this out, not only is the stakes are really high and important, but an example where the company, if you look at the bottom, the company did not apologize. In particular, the company sort of argued with the analysis and said, this is incorrect. You're looking at the wrong metric. In order to look for bias, you should look at how accurate the algorithm is, not this, what happens when the algorithm is wrong. And this gets to an interesting question. What is the right way to measure fairness? There was an excellent talk by a professor at Princeton that's available online that goes into this issue in great detail and talks about at least 21 different ways that you could define what fairness means. And that's a challenge now, because when someone wants to make sure the system is fair, it's not clear how to measure that. So that motivated us. That was one of the reasons that motivated us to do this Fairness 360 toolkit. This is open source, publicly available. It's been around for almost 2 years now. And it has 70 different ways of measuring fairness. It turns out there's more than 21. And not because the world needs 70 different ways, just because that's where the science is right now. Depending on your use case, you may care about different ways of measuring. So for example, you might care about, is the system correct? Does it get the right answer? Or you might care about all the times when it says bail is denied, how often is it correct in those cases? Or the opposite, when bail is approved, how often is it correct in those cases? It also contains what are called bias mitigation algorithms. And this is what's done. It is researchers that are looking at, if a system is not fair, are there ways of making it more fair, basically mitigating the bias? So you're basically using AI to be more just, I guess, in some sense, against an existing AI system. Of course, that raises a lot of questions. Do we trust that mitigation algorithm? And so there's a very active field in this space. Our goal here is not to say, here's a recommendation that everyone should use. Our goal is to capture what's been done scientifically, make it available for people to answer those questions that are good questions about whether or not, which of these metrics makes the most sense. Are these mitigation algorithms effective? Are they useful? Are they dangerous? Whatever it may be. Again, it's not to promote anything particular, but it's to make it more accessible to people, because before this, they were just published in papers. Occasionally there'd be code available, but it wasn't all in the same repository, so you can't compare anything. So that's what this toolkit is about. We spend a lot of time with a demo. I'll show you that in a second, and also with notebooks and ways of using things at concrete use cases. So if you're interested in this topic, I highly recommend you go there. Even if you're not a data scientist or a machine learning expert or a code person, there's still some resources there for you to learn a little more about this topic. Here's a picture of the web page. And you can see it's, there's code that's here, get the code, and that goes to GitHub, and you actually can play with code for those who like to play with code. But there's things where you can read more. You can go through a demo I'll show you in a second, watch some videos, read a paper, tutorials. We have a Slack community where people can ask questions about anything in this space and interact with others, and so on. Let me skip that. So here's an example of how it works. All right, and it's not magic. That's the thing I would definitely want to illustrate here. Just take a pause for a second. So the idea is you would have a data set, and this is what you're going to train your AI system on. And you would tell the system, okay, here's my data set. And we have 3 publicly available data sets just to illustrate, but of course it'd be your data set normally. And then you'd say, I'm concerned about we call protected attributes. So in the data set, there's a field called sex, there's a field called race, and I'm concerned about bias, in this particular case, on both of these. Okay, so you have to tell the system that. And then you would also tell the system, what are the choices? And so usually it's binary, and I realize in some cases it's not, right? But the current technology mostly focuses on binary situations. There's a way of transforming something that's non-binary to binary, and basically checking a whole bunch of cases. But in this particular case, let's assume it's binary. You mark one as privileged and unprivileged. How you mark it doesn't really matter. It just, you'll see in a second, the number will come out either positive or negative, and positive means it advantages the privileged group, and negative is the other way around. So if you flip them, it just means that the values will be flipped. So in this particular case, we're using this adult census income data set that's publicly available. And what we illustrate here is 5 of those 70 metrics and the value that came out, right? So basically it's, calling a function and getting back a number, that's all. And we just illustrated this with this, graph. And so these are 5 different metrics. And what you get back is this number. And here's an example of, +1, -1. And this is saying that it's negative, it's hard to see, negative 0.17. So if it was 0, it'd be perfectly fair. If it's less than 0, it's bias for the privileged group. And then the question is, okay, what do I do with that, right? And this is where the stakeholders need to figure out, is this acceptable? And one place to look at would be, well, what are the laws in this case? Another case is, what's my company's or organization's policies on this? Maybe the law says as long as I'm not lower than -0.2, it's okay, but I don't feel comfortable with that. I want to have something even better. Right? So there's a lot of issues here that are not scientific, that are not machine learning. There really are stakeholders, owners of the product, owners of the company need to be involved in this kind of discussion. So this illustrates other metrics, and the website has definitions of these metrics. Also, on the website, if you hover over it, it gives you a short summary. And it also gives guidance on maybe which metrics make sense in different ways. Then if you wanted to, you could try to do a bias mitigation technique. There's three different ways of doing it. And this is, I would say, cutting edge science here. This particular one says, while I'm training the algorithm, looking at the data and trying to find patterns, can I also try to, in addition to be accurate, try to be fair at the same time? And then, you call basically the same functions again, you get back another number. And this just illustrates the before and after picture. So for this particular metric, it got to be better, right? It's closer to 0. This one turned out it got to be biased in the other way, which maybe is okay, because we're concerned about biased against an unprivileged group. So maybe this is okay because the unprivileged group has a bit more favorable outcomes. Maybe it is, maybe it isn't. It's a stakeholder decision, and so on. And what you'll see in some cases, this is kind of intuitive sense. It was supposed to make it better. But in other cases, maybe it doesn't make it better. And that's just where the science is right now. This is not, not a product saying it's always going to work. It's just encapsulating where the scientific knowledge is right now, and and people can innovate on top of that. One other point I want to make is this one right here. Even though we're focusing on bias, there's also this measure of accuracy. How, the model, in the end, the model is trying to predict something, and how accurate is it? And it turned out by mitigating bias, by making it more fair, in this case, it made it less accurate. And so there's not always this trade-off, but often there's this trade-off that making something more fair will make it less accurate based on the data set, at least. So that's another challenge for a stakeholder to understand, what kind of trade-off do I want to have there? Okay, so that's talking about toolkit. Within IBM research, there's a lot of other innovations going on, and these are just some of the papers. And then finally, I just want to, before wrapping up this section and taking questions, I just wanted to point out that sometimes bias is about people, and that's really important. Here's a case where it's a bias in a different way, right? So this is going back to that scenario where we're looking at sports and we're trying to find highlights, right? So this was some golf tournament, and it was looking at video highlights. And what they did, the algorithm was looking at a bunch of things, such as the crowd noise. If there's a lot of noise from the crowd, maybe that seems like something interesting happened, and therefore we should. That's a good candidate for a highlight. And what they discovered at this particular golf tournament is that some golfers had a bigger crowd, no matter what hole they were on. And also some holes had more crowds, larger crowds, more stands. And so just simply measuring the noise by itself wasn't sufficient because there could be a bias on the actual hole. And so they had to take in consideration not to be biased against holes with a smaller crowd capacity, because that could be, that could be an issue. Clearly the stakes are not as high as the other examples, but I just wanted to illustrate that it's, not just dealing with human decisions. It can also be other cases as well. And then finally, the last slide here is a sort of a big picture slide. And it's trying to show the challenges that someone is building an AI system may have, right? So what we're talking about is, on the bottom here, is trying to avoid any kind of bad discrimination, we'll call it, or differentiation, right? Treating one group differently than another just because they're in that group, right? And the reasons you don't want to do that is it's against the law in many cases. Also, maybe this is not not what I want for my brand. I want my brand to be viewed as certainly fair and not discriminatory. That's generally a good strategy. But what I wanted to point out is the top part here, where there are techniques or reasons why this, we'll call it differentiation, exists that I think we live with and appreciate, right? So one is technical. Machine learning, the way it works is it's looking for patterns. It's trying to figure out who is a good credit risk and who is not, right? In other words, if I have candidate A who's had a credit history, let's say of 30 years, they've always paid back all their credit, and let's say they've been living in the same place or other things, that's probably a good person for giving credit to. And I have person B, who let's say has defaulted on many loans, not paid their credit bills, et cetera, et cetera. That maybe is a candidate that's not as good, or it's a higher credit risk, I guess I would say. And what machine learning is trying to do is look at those attributes and trying to figure out what's the pattern here. Given what you tell me the first one was a good one and the second one was not, if I see a bunch of those examples, can I differentiate what's the, what is the pattern of a good credit risk and a bad credit risk? So the way it works is really to differentiate groups, not social groups, hopefully, but groups in terms of things that matter to the task at hand. And then businesses have this strategy that's probably goes back centuries, is that if I have a new product and I think the whole world will want it, I'm not going to make enough for the whole world initially, because maybe I'm wrong. So instead, what I'll do is I'll roll it out in a selected target group that I think will likely is my best candidate for this thing. So you see this certainly, with ads, let's say apps for teenagers, or other products that are geared towards older people or whatever it may be. So it's market segmentation. So both of these practices, in some way, are trying to differentiate between groups for, I think we would argue, are good reasons. And that's what we want the AI system to do, but we don't want it to do against things that are unlawful or just bad. And that's the challenge in building an AI system, is to balance these two forces. Let me pause for questions before I go on to explainability.
Thank you, Mike. We have a few questions. So for your background, our attendees have a different large background in various fields. So the questions also reflecting that. There's a question actually a comment from Emily from France. She said, thanks, Michael. Your answer that's referring to the first part. Your answer about creativity makes me think that we might have to think more about what is creativity and what is marketing. The example of the trailer seems to me more marketing than creativity. Any thoughts?
Yeah, absolutely. So that was just what popped off the top of my head because it happened to be something I was aware of. Yeah, creativity. I'm clearly not a creativity expert, but without a doubt, there are things you can think of, art or music. I know I saw a few years ago there was AI composing music. But I don't want to limit to my examples. But without a doubt, and I think there's also challenges, and you see things like technical articles that's written by AI. I think there was a famous one from an NYU professor a while ago, where they just mined articles and ones that were positive they used to generate a new article. I forget what field it was in, and it actually got accepted in a journal. So there's I think in all these cases there's opportunities, but there's also ways it could go bad.
Thank you. There's a question from Dragan. That's a tough one. When states design the use of AI for defense purposes within a broader strategy, do they have some kind of specific ethical guidelines? How would policymakers balance the security with ethical principle when state level is concerned?
Right. So I hope they have guidelines. I know like in the US, within the last, I think, year or so, the Department of Defense came out with, I think, something like called the ethical guidelines for use of AI. I don't have enough information to know, what happens after that, but I definitely share the concern that, you're talking about high stakes. That's a pretty high stake.
Thank you. There's a question for me, since you're talking about concern. What are the concerns of machine learning engineers?
So it's interesting. I will kind of split them into two groups. And of course, this is always dangerous. But there are people that are, amazing, machine learning, I'll say machine learning, scientists, engineers, I'll group them all together, who want to make their systems more accurate, right? The people who build, the Watson Jeopardy system, or the Deep Blue system, or the AlphaGo system, or whatever problem they're trying to solve. The people who did the autocomplete on search, etc. And their task is they want to certainly make that more accurate and be usable. You know, there's probably many things going on. Maybe autonomous cars right now is one where, you know, it's not rolled out in a big way. And I can imagine people who are passionate about that want to get it so that it actually works for some definition of works, right? So people who've already succeeded in some degree and people who want to succeed, they're focusing a lot on accuracy. But what I'm seeing in the group I know more about is a considerable concern about all these issues we're talking about here. That, hey, that may not be enough. That there's other concerns, as fairness, explainability, we'll talk about in a second, and so on. And so I'm seeing a significant, I can't tell what percentages, but a significant number of machine learning experts who are saying, hey, we've got to pay attention to all these kinds of issues. So there's a conference called FACT, F-A-C-T, Fairness, Accountability, and Transparency, that just started 2 or 3 years ago. And it basically initially came from the machine learning community, and it was a subset of those people who cared about all those issues and trying to, you know, help raise awareness and quantifying. What's been great about that community is it's got all the other important stakeholders, sociologists, public policy, psychologists, philosophers, lawyers also involved there. And a lot of the work I cited before of examples, you know, that people have studied those things in great detail. So they're coming together in these communities. There's another one that ACM sponsors called AI Ethics and Society. It's another annual conference where it's a similar thing where people are coming together. So to answer the question, I guess I would say that there still are a large number of people who are working on the accuracy problem. But there's a lot of people who are basically, who used to be working on the accuracy problem of machine learning, who are now saying, all right, that's nice, but this fairness aspect is very important, and they've kind of, you know, moved over to work on that with the social scientists.
Yeah, thank you, Mike. Another question, in your list of example of AI that somehow did not produce the expected results, you listed a number of companies. How come you didn't mention IBM?
In the slide that has 9, well, those examples were not IBM. I mean, a lot of the, so a lot of the cases where there were issues coming up tend to come from companies that work with consumers, right? So I'm guessing everyone has a Google account for whatever it may be. And so that's why, that's what was in the press. There was one case with facial recognition, which was in the slide that had the 9 squares on that, where IBM was one of many companies. IBM, I think it was Microsoft, and a small company. And there's been more developments about that as well.
There's another question from Joanna that is referring to one of the tools that you show. In particular, there was something about the mitigators. Who is deciding the right mitigators?
Right. So very important question. So the way to think of this, this is a rough analogy, is what these tools are supplying are hammers and screwdrivers and wrenches and things like that, right? And then someone's going to build a house or do something constructive with them. So we are definitely not saying that if you care about fairness, use this toolkit and everything will go away. That's not the message. The message here is that there are people publishing papers on how to measure fairness. There's also papers published on how to mitigate fairness. We think society could potentially benefit from knowing those papers, and we're taking the code from those papers, or the ideas from those papers, and putting in code, and then people can decide for themselves. This is not a product. This is an open source toolkit that people can use to explore and to compare. And we feel that's the best way to sort of shine a light on these ideas, so that the authors and the research community can get feedback on whether or not they're useful. So it's not, it's just making them available, making these tools available, and then people can decide, what's useful, what's not. For example, those mitigation techniques, no one's compared them at all, right? Because they were all implemented for papers and in separate systems. And so by having them all in one system, someone can do a simple experiment of comparing them. The use case we foresee here is quite often an enterprise will say, okay, I've got a particular problem. Maybe it's I'm rolling out fiber optics and I'm concerned about bias to the neighborhoods I'm rolling it out. I want to know, am I biased on zip codes or whatever you use for your neighborhood? So you can use this tool to measure that. And then if you discover there is a bias, probably what you'll do is you'll say, okay, something's wrong in my training data or just the way I'm looking at the problem, and I'll fix that myself. But you could, if you want to, also use one of these mitigation algorithms to see how well it does. If a big if, you do use one of these algorithms and you see it gets better, you should understand why it got better and what happened to the decisions, right? Because it's potentially changing decisions. Maybe the accuracy goes down, but it's supposedly more fair. You really need to understand that. It should not be used in any kind of blind way like we use tools for, for other things.
Thank you. There's a last question that I think is actually related to this one here and also to your answer. It's from Emily from France. She says, I wonder why you consider that we do not need different definition of fairness. Perhaps we do need different understanding of fairness. Is this not a negotiated space in society which needs to be shaped and reshaped through dialogue? The question might be what it means for AI. And if I could maybe add a little sentence on that, when you have a tool and you have a code where you see a value in a parameter, this is unlikely understandable from the people that Emily is talking about. So how do you bridge the gap?
Right, okay, so two questions there. So yeah, so earlier I said that when there are 70 different ways of measuring fairness, not because society needs 70 different ways. So I should be careful. That's a good point, Emily. What I meant to say there was an enterprise who cares about their product being fair would love to say, what is the way to measure this and to measure it for their particular product? That's what they would like in an ideal world. As Emily pointed out, depending on what you're trying to be fair about and what your use case is, there are different ways of measuring it, and maybe there'll be more that depending on how we advance as a society and understand that very hard topic. So that's part of the reason why there are 70 different ways, at least, because there's different ways of looking at the problem. So I definitely agree that it should not be computer scientists who define how many different ways. It's a society problem, and sociologists have looked at this and will continue to look at it. So it's very important that it matches the particular use case and the needs of society. What I was talking about is a company or a group would like to know what is appropriate in their case, working with someone whose expertise is in that space. And then they would like to measure that. And maybe they have to measure it, 5 ways or 10 ways or whatever it may be. But in general, people would like to have, the less metrics to look at, the better. That's just a pragmatic aspect. But I definitely agree that society needs to define what's important, what should be measured. And sorry, the second question, I lost it.
Yeah, the second question was, I think Romeo in his presentation shows some code where, at the end, you had to really look at the code to look at value to understand a meaning of one of the fairness criteria. So that's something you can't really show to people that are not programming expertise. So
right.
how you bridge the gap?
Yeah, exactly. Yeah. So in the U.S., right? You just go back to the related question of I got a 0.13. Is that bias or not? Is that acceptable or not? Even in terms of regulation, there's really, in the U.S. at least, not a clear definition of if that's okay or not. The closest we have was a court ruling that kind of implied 20% might be okay. That's in the US. I'm not sure what, how things are in the EU. So so to net of that is, it's not clear what the laws are and what's acceptable for any particular metric or bias. But your point is to saying, well, even if it was clear, or a stakeholder had to make a decision, how do they think about 0.13? What does that mean, 0.13? And without a doubt, I definitely want to emphasize this. We are not saying that, okay, machine learning or a systems person can just quantify all this. That's not the message. Hopefully that's not what people are hearing. What I'm saying is that right now, there's this huge gap between the concerns, the very good concerns that society has, and the way these systems are working. And this is a step to say, can we quantify a bit for these various metrics, quantify, measure what bias is, and then that goes into the people who understand this domain the best. And those are not machine learning experts. That's the people who understand, fairness and society and all that stuff. And a related question would be, am I saying that companies who are in this space should be hiring and consulting with such people? And the answer is absolutely yes. They are very needed. And it's not just a lawyer part. It's also to understand, if I roll this product out and it's going to have this level of bias, what are the implications for society and social responsibility in general?
Thank you, Mike. We'll let you continue then.
Okay, thank you. This is great. I really appreciate the questions. Okay, so explainability. So there's been a lot similar to with fairness. There's been articles talking about AI and AI not being able to explain how it comes up with decisions. So on the top here are just some headlines from various publications, basically making that point. On the bottom are two examples of a company or an enterprise that had an AI system that was better than their current function, what they were currently using, and they could not use it because there was some law that said it needs to explain itself. And I think that's reasonable. The only point I'm making here is not that, it's not the case that, oh my God, the law prevented this from happening. It's good, probably, the law prevented this because explainability is important. So two things. One is the top points are basically saying this is a problem that has reached mainstream media. And the bottom is basically saying it's prevented some newer algorithms from being deployed, which is probably a good thing. I want to just go a little more details here. There are laws that talk about the need for explainability. So the top is a deck from Paul Nemitz, who was one of the primary authors of GDPR. And as I'm sure everyone knows, GDPR is mostly about data and data rights and data protection. But there is an aspect there that talks about automated decision-making. And this is his copy of his slide that says that if you're going to use a system that's basically an AI system, then there's a right for citizens to have meaningful information about the logic involved in the decision. So essentially an explanation of some sort. On the lower right is a state in the United States, Illinois, and also the city of Chicago. They passed a law, and it was about video interviews. So the concern is that you do a video interview, completely automated, and then you have an AI system that grades the candidate based on however it's been trained. And of course, there's a lot of things that can go wrong with this. And they passed a law that says, if you do this, you have to do a certain number of things. The part that's highlighted there says you need to explain how it works. Okay, so again, that seems quite reasonable. Both of these cases seem quite reasonable. But there's a challenge, and the challenge for people building these systems is, what do you actually mean by explain, right? What does an explanation mean? How do I know if I've given an explanation that's satisfying, right? And so what I want to do, actually, let me skip ahead for a second. I'll come back to this. Oh, wow. Okay. There we go. This just sheds a little more light on the challenges here, right? So here I have my AI system, right? It's a proverbial grayish box, and it's made some kind of decision. And I've got various stakeholders who want an explanation, right? So what I'm doing here is trying to go a little deeper on what might it mean to have an explanation. And I want to, what I'm illustrating is that basically each of these stakeholders, it's going to be the explanation is probably going to be different for them. So on the left, we have a data scientist, and she wants an explanation for how the system works, probably because she wants to improve the system. She's probably debugging the system, wants the accuracy to be better, and so she would like an explanation. She knows a lot about data science. She knows, the field. So the explanation I give her could be very, very technical. Over here, we have a developer. This developer is different than a data scientist. They know about coding and programming and calling functions, but they don't know all the lingo of data science. And so an explanation for them may be a little different. I mean, if you're not one of these people, maybe you might think them they're the same, but they're actually different. Over here, I have a physician, and she certainly is a deep expert in the medical industry, but she's probably not an expert in machine learning. So she would like an explanation that uses the appropriate terms from medicine, but may not necessarily appreciate, technical terms related to machine learning. Here I have a regulator who wants to make sure the system is fair. It's not clear what background they will have, certainly a legal background and social background, but maybe not necessarily an AI background. And so the information I give that person needs to be, in the language that they can understand. And then here I have my dad. My dad went to the physician. He has a rash on his arm, and he's wondering if it's cancerous or not. He knows nothing about medicine. He knows nothing about machine learning. But when the doctor tells him you have cancer, he'd like to know, why do you think that? So he wants an explanation as well. Right? And so the point here is that when you say it needs to produce an explanation, the first question I have is what kind? For who? Who is listening to this? And and we can relate this certainly to everyday life. Right now, I'm trying to explain a concept. I might be effective or not, depending on your background or how effective I am at explaining things. And so it's very much a two-way street here. And I know there's been, this problem has been studied certainly in philosophy and so on. So I'm just pointing out what probably a lot of people know is that when you say it should produce an explanation, it'd be nice if it was more concrete so we can know whether or not we satisfied that. So what I want to do is go back. I apologize for this. And just explain for those who don't know a little bit about how machine learning works and why this problem is very challenging. I've given a similar talk to congressional staffers in the US who are considering regulation. And often they were, I'd say, have the wrong perception on how this works. Like, for example, they would often ask, why does a programmer put biases into an AI system? And this little story, this example, hopefully will illustrate how it works to better understand how hard it is for explainability. So let's just play a little game. Bear with me here. Here's a sequence of ones and zeros. We have a 1 followed by 3 zeros, a 1 followed by 3 zeros. And as a human, I'm asking everyone to predict, what do you think the next number is going to be? Right? We only have ones and zeros in our world. It's very simple. And if you said 1, that was probably a good guess, right? And that representation of ones and zeros could be used to model many different real world situations. So in the US, we elect presidents every 4 years. And so if 1 means yes, there was an election, and 0 means no, there wasn't, those patterns of ones and zeros could match this problem, right? But the computer would see the ones and zeros. It could also match a similar problem that's, I mean, a totally unrelated problem. When is there a men's World Cup or a women's World Cup, right? It turns out it's every 4 years. The years are different, but the pattern is the same, right? So seeing this pattern, an AI system could say, well, the next one is one. In 2022, there'll be a men's World Cup. Um, and then this pattern also exists in my family. My mom had 3 kids. I was one of them. And it turned out every 4 years, a child was born. My older brother in 59, me in 63, and it turned out, yes, my sister was born in 67. So it's the same problem of ones and zeros, but what it means is very different. Here's another problem. Full moon. I want to predict when a full moon is going to be. And this was, I think it was last year. These were the weeks where there were a full moon. And it turns out that, yes, on the week of the 11th, there was a full moon. Okay. Here's same problem, but different dates. I shifted it. And you might predict that the week of September 8th would be a full moon. But it turns out that's not the case, because a full moon is not every 4 weeks. It's actually a little bit longer. So sometimes there's going to be an error, and sometimes the pattern recognition won't work so well. So to summarize those little examples, is the way machine learning works is observing a pattern, right? It's looking for the ones and zeros, but it's not understanding what they really represent. This goes back to what I said before about the pixels of the snow and the polar bear. It doesn't understand what a polar bear is. It understands if the pixel is white or black or gray. And what I just talked about here, it understood the pattern of 1 followed by 3 zeros, but it did not understand things like years or weeks or elections or World Cups or so on. Machine learning doesn't have any explicit rules. It's learning the rules. So there's not really a person that creates the rules. It's just learning the rules using math. It only makes these conclusions based on the data it sees, right? So if we trained a system to observe the temperature in San Diego, California, where if you're not familiar, it's pretty much always 68 degrees Fahrenheit, then it might say, well, temperatures are always the same. Every day, it's always the same. And that's certainly not the case in New York, or I'm guessing in Frankfurt. It definitely are seasons and things vary. So if you, depending on what you train it on, that's what it will conclude is the pattern. It can explain a pattern, right? So if we asked it, we could explain, 1 after 3 zeros. But usually the problem we're asking is something deeper. This is just an abstraction of the problem. So it has no idea about, let's say, the US Constitution or what FIFA says World Cups, or the astronomic principles about full moons, or what my mom had in mind when she was giving birth to her kids. And sometimes it's wrong when the data is not fully representative of what the underlying phenomenon is, right? If you just have, the full moon example is a good one, where it looks like if I didn't train it on any cases where it turned out it was every 5 weeks, then it would definitely conclude it's every 4 weeks and be wrong. Here's another example that I think illustrates some of the challenges between machine learning and, I would say, public policy, which I think is, for those who are on that side, is, I think, a really thought-provoking example. So I'll start out with some motivation. This example, we changed things a little bit. We now have 2 what are called features, or 2 answers to questions. What is the gender of a person, and what is their age? And we're trying to predict whether they prefer an app called Snapchat, which is popular with younger folks, or an app like, say, Waze, which tends to be only useful for if you're driving, mostly useful if you're driving, so it tends to be older folks. And let's say here's our data set. This is all made up. And hey, I've got 2 young people, didn't matter what their gender is, they like Snapchat. Here I have 2 older people, didn't matter gender, they like Waze. And if I ask them to predict, here's a new person who happens to be male and 41, what's their preference? The system will probably, predict Waze based on this, made up data set. Okay, so another example, and this gets to the more interesting question. Here I have, again, a similar thing. I've got gender and age, and we're looking at insurance risk, or in particular car insurance risk. how are they low, a risky driver, or a high, based on these categories. And at least in the US, I'm guessing it's more universal. What the data has shown is that men who are young tend to be higher risks for car insurance than pretty much everyone else. I mean, it's more involved. Men in general are higher risk than female, but particularly in this very, very simple case, young males are very high risks in general. Okay, and so the question is, can I use this fact? This is actuarial science. Can I use this fact in deciding insurance pricing, right? In the US, the answer is yes. The answer is yes. These people are more likely to get into accidents. It's more likely to cost the insurance company money. So therefore, they should pay higher premiums, right? So it's an example of finding patterns in data and then using that for policy for the company. And I'm guessing most people don't have a problem with this. But then it gets to be interesting. Here's a related problem. In the US, life expectancy for males is lower than females, right? Back from last year, it's actually significantly lower. It's 5 years lower. So people who are doing life insurance or doing, let's say, retirement benefits, could they use that information to price appropriately, right? So for example, if a male is more likely to die than a female earlier, then maybe they should pay higher life insurance, would be one example. Another one, if it's for benefits, a female is likely to live longer. Should they be, I don't know, somehow pay more because they're going to, benefit more from their retirement benefits? The answer in the US is absolutely not. This is not allowed, okay? But if I'm a machine learning person or an actuarial, I look at the data and I would conclude, well, this is what the data is telling me, and can I take action on this? And so my point here is not to say whether any of these are right or wrong. My point is to raise these because in my mind, I think there should be some consistency, right? I think if this, using this information for pricing bothers you like it does me, then why does this not bother people as well? And so, again, this is not an AI or a data science problem. This is one I think society needs to grapple with and figure out what the answer is here. Okay. So in summary for this section, what I gave you was some simple examples just to illustrate points. Generally, the first case in there was one feature and it was the ones and zeros. The second case there was the age and gender. Real AI systems have millions of features. If you think of a photo, every pixel is a feature. And so it's using all those different things. So in the end, these features are really just ones and zeros, lots of them. Like you might see something like this that may be 1 million long and it decides it's a cat or it decides it's a dog. And now when we ask, give me an explanation for why you think it's a cat or a dog, the explanation is going to be it would be communicated as these pixels, as these numbers, which is not what humans want. So the point here is that when you say an AI system should explain itself, it's really thinking, I guess in quotes, it's a very different way than we as humans think. And so it's challenging to be able to give an explanation that satisfies humans the way we communicate. This is not to say it should not give an explanation. That's not my point. My point is just for folks who want to understand how hard this is or the challenge that's there. Okay, so what we did is so there's been a lot of work. There's another community focusing on this problem of, given those challenges, how can we come up with explanations? How can we come up with techniques for giving explanations, right? And also keeping in mind that it's not clear what an explanation is, right?
Could I interrupt you for a second? There's a question from Chris Clifton.
Okay.
And actually involve a comment. He said, be careful saying in the US, for auto insurance rates, differential pricing based on gender is not allowed in Montana since 1985 Hawaii, Massachusetts, North California, and Pennsylvania, and most recently California.
Excellent. Great. Yes, yes. So one clarification, I was a little sloppy, is insurance rules are based on the state, not on the country. So saying the U.S. is definitely wrong. And yes, I'm glad to hear that people are thinking about this problem, and those states are doing something. But yeah, I think it's a fascinating topic, and thank you for helping me clarify that.
Yeah, thank you.
So again, we built this toolkit. It's similar at a high level. The goal here is to bridge the gap between what researchers have done in explainability in terms of ways of explaining things, and then to let other folks give feedback on whether or not these techniques would be appropriate for satisfying whatever need they may have, okay? Again, it's not meant, this is not a product. This is open source. Anyone can contribute, do whatever they want with. And the idea is to take what science has done, what's been published, and let people make it a little more accessible to them to understand and to play with and to give feedback. In this case, we have a Slack channel, and those not familiar with Slack, it's a way of having conversations. And that's what we're really trying to do, is to get conversations from people with different expertise to give feedback to researchers, because we don't want the researchers to be working only in their community with their peers and convincing themselves they're doing the right thing. They need feedback from society in general about whether or not this is a good direction or not. So this has a demo as well, and a bunch of notebooks. If you're not familiar with the term notebook, it's a data science tool that allows you to do various data science tasks in a nice visual way. And we have a whole bunch of different use cases there. So it's a way to help make things more concrete. And there's also a paper. What I'm going to show you, let me show this chart here to, and I realize a lot of you won't be able to understand it, but the point here is that it's kind of getting to the issue of, what do you mean by an explanation? So it's the beginnings of a roadmap to understand which technique might be appropriate, right? So for example, you start at the top and you say, okay, you want an explanation. Do you want that explanation to be static? And what we mean by that is, think of it maybe a printout, right? Here it is, here's the explanation, we're done. Or do you want it to be more like, I think what humans do, interactive, right? I explain things, you ask me questions, I try to clarify, and so on. Most of the work in the field is on the left-hand side. There's not much work yet on the right-hand side, despite that's what might be actually very interesting. Then if you get a explanation, is it trying to explain aspects of the data or aspects of the model that was being predicted? Mostly what I've talked about has been the model side, but you can also look at the data and see and try to explain some features of the data. When you focus on the model is the AI system, you can be, am I trying to explain a specific decision, why was I denied credit? Or am I trying to explain how the whole system works? So a regulator might be interested in the latter, how a whole system works. Whereas, my dad going to the physician wants to know, why did he get the diagnosis that he got? And then as you get down here, there's different ways of doing things. There's what's called post hoc, which is basically saying, I can give you the explanation after the fact, right? So if my child doesn't do what I told him and I ask him why, he'll tell me why. Maybe that was his thought process, or maybe it wasn't. Maybe it was something he conveniently made up to answer my question. That's kind of what post hoc works. Self-explaining means while it was happening, you're explaining it. Somehow you're kind of inside the head of the machine to get the explanations, and so on. So I don't want to go through all the detail. The paper talks about it in more detail. The main point here is that a lot of the field right now is focusing on this path down here, this features path, right? So a lot of the techniques, if you're following this field, are examples of this. And one of the things in the toolkit is we're showing there's many different ways, and we have examples of, certainly not all of them, because there's a whole big branch missing here, but trying to show different ways of doing explanation. And I'll illustrate that with an example here. We think they're appropriate for different kinds of people. So here's a case where there's a loan approval case, and I've got 3 different people: a data scientist, a loan officer, and a customer. So a data scientist might want to know things like this, like here's the overall score. This is looking at risk. Should I give the person credit or not? And it's trying to get a feel for the various features, the various answers to the application, the credit application. When are they significant or not, right? So if you're not a data scientist, this probably won't make too much sense, but this was something a data scientist would like to see. Here's a loan officer, right? And this view is different. Robert is the person who applied for the loan, and here are all the features. This is a real data set, which is good, but also bad because some of these names might not make much sense to folks. But this came from the FICO data set, and it's a credit agency in United States. And so these are their values, and the details don't matter so much. This particular person was rejected, and the system came up with 3 example people, right? You can certainly anonymize these names. You should anonymize these names. And it says that this was rejected because the system thinks these values in aggregate are similar to these 3 people who we trained the system already defaulted. And that's why we recommend Robert should not be approved, but Robert is a high risk, right? So it's kind of explanation by other examples that you trained it on. And then finally, this is the bank customer who probably doesn't know that much about machine learning. And the idea here is, well, Jason's was denied, application was denied. And the reason why was basically there were 3 factors that were important. And these are basically answers to the questions. And it tells you the values they had. And it says if it was, rather than 65, it was 72, then the application would be approved. So it's a little more actionable in terms of what Jason can do to actually make the loan, make the application more likely to be approved. And this is a different technique that does that. So that gives a flavor of the various technology of where things are now. Again, this is just capturing what's known in science right at this point. And it can enable a dialogue. So for example, a person writing like that Illinois regulation could say, hey, explanations like this are good. Maybe this is what I would like my citizens to be able to have. Explanations like this, maybe I've got too much concern about privacy issues or something. I don't know. Explanations like this, are not not useful to anyone except for a data scientist, and that wouldn't be good, or whatever it may be. So the idea is to show examples so that we can actually have this dialogue between data scientists and people writing regulations. Let me pause before I go to the next section, which will be a very brief one. Any questions?
We don't have any questions for this.
Okay, good. So I'm running a little late, so that's good. Okay, so robustness, Roman spent a lot of time on this. Again, this is a scary chart. Sorry for the image on the right. There's been articles, again, people talking about how AI can be hacked, can be fooled, and so on. And here's examples I think Roman went through similar, Romeo, sorry, where you've got, you can trick an AI system that sees a stop sign normally, and when you put a post-it on it, it suddenly sees it as a speed limit sign. There's examples where you can sort of understand the training data of how things were trained. And here's another one where this person put on these glasses and was recognized by this famous person who I don't actually know, but maybe someone does. So we put out a toolkit. This was actually the first toolkit we put out, which has contains ways of defending against attacks, and also quantifies known attacks that have already been published. So people who are interested in this space can, again, it takes what's been known in science, puts it available, and so that people can give feedback and understand things and improve science in a more accelerated way. Okay, I'd like to spend the last 25 minutes on this very important topic of governance and transparency. So, and you'll see that we have this idea we call fact sheets. And I just want to mention sort of two use cases. And so the last section will be partitioned amongst these two use cases. The first use case is on what we call transparency. And this is the idea is you have an AI system and you want to know, can I trust that system, right? For many reasons. Maybe it's because you're concerned about bias, concerned about explainability. I want to get a general sense of trust. And you can think of this as more as, you know, I'm buying a product and I want to know, you know, what's the level of risk here of this product. So therefore, tell me something about it. That's this use case. I'll talk more about that in a second. The other use case is around AI governance, which is I want to have sort of more control over how my enterprise builds things. And I'll talk more about that as well. So first, the transparency. People who are using a model, and this could be maybe I'm a developer and Roberto developed a model for detecting credit worthiness, and it worked really well in Germany. And I have a very similar need. And rather than go and develop a model myself, what I'm going to do is I'm going to ask Roberto if I can use his model. And so there's a question I might have is, well, where am I going to deploy my model? Maybe I'll deploy it in New York or in the US. I want to know, is that, how dangerous is that? It worked well in Germany. Will it work well in the US? And underlying that is, well, what was it trained on in Germany? And are those sort of universal things? Or are they things specific to Germany? Or maybe the US is specific in itself that it would work well anywhere except for in the US. So I want to know a little more than it worked well about how it was trained and so on. I may want to apply a higher rigor in terms of fairness to that. So I want to know information about that. I want to know about, you know, can it be attacked? And is it explainable? So all these kind of general concerns we've been talking about. Now, a lot of folks will say, well, there's a simple answer to that. Just have Roberto make his code available for me or for anyone, and therefore we'll have full transparency and the problem will be solved. The challenge with that is full transparency of code. First of all, you're limiting people who can understand it to those who understand code. Second of all, with AI, making the code available means really the pattern recognition of ones and zeros. And even the data scientist, in this case, Roberto, who trained that model, doesn't really understand how it works. So making the code available is not going to really solve what you want. You could do that, and some people do that, but it's not really sufficient for what most people want. They want to know basically how it works and what it does on the important characteristics we're talking about, such as the training data set being biased or it being explainable and so on. So when we talk about transparency, this is not a new idea. It's been around probably for a very long time. You can imagine when, you know, people were selling things in an old-fashioned market, they wanted to know, you know, how did you build, if there was, you know, maybe selling produce, you know, how did you grow this? Or, you know, would you use pesticides or whatever it may be? So what I have on this slide is some examples. So I think in the world, but certainly in the US, there was concern about labeling on packaged foods. This was in the 1960s, where people were using terms and consumers didn't know exactly what was in the packaged food. So there was a consortium that took actually 20 years to come up with, you know, what I think is universal around the world, this idea of a nutrition label. They probably vary from region to region, but tell me something about things that I care about. It's not necessarily how it was built or how it was made, the food, but it's some information that's useful to me as the consumer, such as, you know, calorie content and other things like, you know, sodium, cholesterol, and so on. So that gives you some level of information. The bottom left is, I think, something again in the US, which is 1-bit information of is the appliance energy efficient? And clearly there's more information available about the efficiency of appliances, but to make it very, very consumable, it's 1 bit. Either something is Energy Star or is not. In the middle, we have bond ratings, which is, people may buy bonds and they want to know the level of risk. And so you have these companies that will give them ratings, where, higher ratings mean it's less risky, at least in theory. And then on the right, of course, there's many standards, and the right is children's toys, again, a 1-bit example. So based on this, motivated by this, we came up with this idea of fact sheets for AI services. And it's not exactly the same as what we saw before. It's much more detailed. So it's an idea of here's a bunch of questions that someone should answer. What is the intended use of this AI service? In the case of Roberto's example, it was to do credit worthiness, and then other things. What were the data sets it was tested on? How did you test it? Are you aware of examples of bias, ethical issues, and so on? So questions that will help me, the consumer of that model, to determine whether or not it's appropriate for my use. This idea is there's a lot of groundswell around this general idea of increased transparency. Probably you're familiar with the EU's assessment list. So back in April of last year, there was a commission put together, and they came out with a draft guidelines of about 100 or so questions, sort of similar to what I just showed, that they were considering having companies in the EU, requiring companies to answer before they can deploy those systems. And they asked for feedback. I think several hundred volunteered. That feedback has happened, and the EU, I think, pretty soon will be coming out with updates to this, updates to the questions. And this could eventually lead to regulation, sort of like GDPR for AI systems. So going back to the idea, I'll make it more concrete in a second. We feel that there's not going to be one magic appropriate nutritional label for AI systems. It's going to depend a lot on who the system is for and who's the target user. What do you care about in a system? You may not care about the same things I care about. In my example, Roberto and I may not care about the same things. Maybe he cared a lot more about bias than I did, for example, or adversarial attacks are not an issue in his case because it's all inside his company and there's no way to attack it. Let's say it's only being used by a loan approval officer there, where in my case, it's going to be out on the internet and I care more about attacks. So we feel that there's a need for this, what we call a template, which is to specify what are the questions that make sense in your particular use case. And so you develop this template. It could be for a use case, for an enterprise, for an industry, regulatory body, whatever it may be. And then you answer those questions, and then what you get out is the fact sheet. Here's one example, just to make it concrete. The details don't really matter much. They matter, but not, for illustrative purposes here. You would have this template which would say, what is the intended use? To be more words, of course. I'm just, abbreviating here. How important is this model to your enterprise? Some enterprises, if it's very important, they do extra scrutiny, for example. Information about the data set, and so on. And then here would be the answers to those questions. Of course, this is abbreviated because it'd be much more detailed. This information could be a report, could be printed, or it could be viewed in different ways, right? So it could be, maybe it's part of a web tool you can browse. Maybe it's part of one of these notebooks that data scientists use. Maybe it's a presentation that you show to an executive. We have experience over the last year and a half actually producing these fact sheets. And this was a paper we just published recently. I'll just give you some of the highlights about it. So the questions we had were as follows. When you document this information, there's a lot of different people and that are involved in creating the AI system. And then, of course, people who care about it. And the question was, will they be useful? And if so, how hard it is to create these things? Because we're asking a lot. So what we did is we went through a process, and there's more details in the paper, but we went to data scientists and asked them about what kind of information do you think might be useful. Ideally, we would go to people who were going to consume this information. In this particular study, we didn't have those people available. That's definitely needs to be done, and hopefully we or others will do that. Then we went and actually created fact sheets based on what we learned in the first interviews. So cutting to the chase, because we're a little short on time, here's what we found out. People felt that the completed fact sheet were valuable. They discovered that information, this is basically facts or answers to the questions, that quite often they forgot what the answers were. That they knew it at a time, but then they were quickly forgotten. There was concern sometimes that they may reveal too much, not because they necessarily reveal negative things, but because they may give away too much information to a competitor who's trying to build a similar system, and then therefore you're kind of giving away your, the value you have for your company. So there's a tension there between being transparent so that citizens' rights are upheld and they know whether or not bad things are happening, but not giving away too much so that you actually have a company. So that's a challenge. We found that quite often people who were building a system didn't always know what those who were going to be using the system wanted to know, right? So, this is not surprising. And it really underscores the need to have further studies that are talking to people who want to have this transparency and what information you want to do. And we have work going on that space now, but it's not yet written up. And then the big thing is that these are really hard to create. And I'm be curious to see what the EU learned from their feedback, because again, it's another tension. Without a doubt, citizens have rights, and we need to have regulation that upholds those rights. But it would be good to understand the challenges we're going to be putting on the companies to meet the regulation in the space. So the recommendations are, it would be good to support sort of automatic way of gathering information before people forget things, have tools to help them do these things, have consistency, and to support the way of sort of rendering the facts, which is what we mean is, what I showed before about a tool or a PDF or whatever. And then the two takeaways we got that this really illustrated, and this is where this work, I'd say, is different than others, and that is we still feel that there's not going to be one magic set of answers for every single use case. Maybe one per industry. Like maybe if you're talking about image recognition, maybe there's a set of questions that make sense in that domain, but that might be very different than other domains. Okay, here's an example. I don't want to go through that. It's too much detail. Some references. I'll give a link later on that will have even more references of people. All this work pretty much started in 2018. And there's been, similar ideas. So let's see, time-wise. Okay, let me just try to wrap this up in 5 minutes to let more questions come. AI governance, the idea here is I have an enterprise and I want to make sure, maybe I'm a central location, I'm a chief risk officer, a chief data officer. I want to make sure that I have control over how my AI is built. Because I want to do things in a rightful way, a responsible way, or B, maybe I'm regulated and I definitely don't want to break the law. So I want to be able to sort of specify policies of how AI should be built. I want to be able to document things so I can check those policies. And I want to have this information accessible to everyone in the tool chain, everyone who's building the AI or testing the AI or deploying the AI. I want to have it all available. So what we've learned is these requirements exist already, particularly in financial companies where they'll have this process called model risk management. And they often are requiring their data scientists to write a lot of documentation In some cases, we've heard hundreds of pages of documentation, which is not necessarily a good use of a data scientist's time. They are good at data scientists. They may not be good at documenting things. And what we have learned is that it's not, right now this is very manual and error prone. And so is there some way of automatically capturing this documentation or capturing some of the documentation as the system is being built? So to illustrate the idea, here's a picture of a life cycle for building AI, right? So this is somewhat simplified. We've got a business user, Joe, who says, hey, I think if I use AI to do something, it will help me save money or be more accurate or whatever. And it gives that information to the data scientist or a group of data scientists, in this case, Priya. She does some development, builds a model, and gives that to Dina, who then is an application programmer. She takes that model, builds a full application, and that goes to someone who does testing. In this case, Jane, she does testing. She may say, no, this is not good enough, and goes back and does some iteration. Or maybe she says, this is good, let's deploy it. And then it gets deployed. It runs, and while it runs, there are many people who are looking at it to make sure that it's operating as expected. And so the idea is, as we go through this life cycle, each of these personas contributes some facts about the model or the system as it's being built. Joe may know, why the system was being built in the first place and what's the risk level. Priya will have information about the data sets and so on. And so this is what I showed before. It's just broken down into each role, the information they contribute, which could all be basically a fact sheet for that model, so you have information about it. Here's another illustration, same idea. I've got, just in this case, only 4 personas. They have various facts. It gets put in some place, and then various people can kind of query that place to get information out. And I'll give you an example. So here's a case where I have an AI system, and the data scientists measured things like accuracy stuff, measured fairness, measured robustness, measured explainability. Don't worry so much about what these metrics mean, just that you got a number out. And then the tester, the validator says, okay, I'm going to now validate on a different data set. And I want to see if your system is robust enough so that it actually works in general, not just on the test data set you looked at, the data scientist looked at. And they got some numbers, and these are actually real numbers for a particular credit scenario. And it turned out they're pretty close. And so the validation person may say, okay, this looks pretty good. I have some level of confidence that this model is not just specific to that data set, it actually works on other data sets. So I approve it, it goes out into deployment. And then when it goes out into deployment, you'll get totally new data that no one's seen before. And you can measure these same numbers. And you can see, in this particular case, these are synthetic numbers, but it's illustrating that, all right, maybe it's not as good, but it's in the ballpark. And now if these numbers are not acceptable, then a person can say, hey, wait a minute, let me go back and pull this model and go back to the drawing board and try to fix it. Or you can just monitor it and say, okay, this is good for now, but let's see what happens tomorrow. Another scenario is that often the data scientist will say, okay, the validator, the person who's doing the testing, I've got this model, and this is what the data scientist measured it on. I'm going to look at a new model that's simpler, right? That has less risk, it's simpler. And I want to see if I could solve the same problem with a simpler model. This is called often a challenge model. And the idea is if it's a simpler model, there's less risk involved. So they measure with the same data set, in this case, the validation data set. And the validator would discover, okay, this simple model is actually not performing as well, which is expected because it's very simple. Therefore, the data scientist, the extra complexity in that model is probably worth it. Okay, so just wrapping up, there'll be a lot more information about fact sheets. Right now, there are 2 papers that are published. Within a few days or weeks, we'll be coming out with a website with a lot more details of what I described about. One of the things it's going to have, like the other projects, is a Slack community, again, which is just a way where anyone can join and ask questions and have discussions. And this is a way that will bring together people who want to work in this space. And then finally, this is just a summary. I'll leave the slide up of the 3 toolkits that are out there now with the URLs. All these you can just search for, you know, the name Fairness 360, Explainability 360, and so on. So let me pause for questions.
Thank you, Mike, for the very interesting presentation. We only have 5 minutes, so we really are at almost at the end. There's one question that is related to the fact sheets. So these are almost like a self-assessment methodology. What about, are you working also on post-deployment? So assume that somebody receives a product and you're not really part of the design team, and you would like to see whether fairness or explainability or all kinds of other features are satisfied over time. Is there work on that?
Yeah, actually, the fact sheets work. Our view is that it would include deployment time information. That was, yeah, actually here. The AI operations engineer is basically monitoring the system as it runs, and it's facts about the performance, about model drift, which basically say how is accuracy changing over time. That would be part of the fact sheet. There's an issue there because you don't want to capture everything because that's going to be too exhaustive. It could run for, you know, days or months or years. So it'd probably be some kind of summary there. And there's further technical issues that come up with that. But yes, our view is you want to collect information about how it was built and also how it was deployed.
Thank you. But I assume that this does not include the case where you are using the product, but you have no access to the designer and the engineer, and you want to monitor the performance of the product deploy maybe by somebody else.
Yeah, so there are, in fact, IBM has a product in this space that does exactly that. It's built, a model was built somewhere else, and then you want to monitor it. And what it actually does is it monitors it for bias, and it also monitors it for explainability, and it can produce, you know, reports. So yes, you could have a fact sheet that's just the, you know, the runtime characteristics. You could certainly do that.
Thank you. Maybe I should mention the last question because we're really running out of time. Is from Magnus from Finland. Should AI be seen as a competitive advantage? Question mark. Should a fundamental technology be open for all, including preference to a competitor?
Including, I missed the last word, last 2 words.
Including transfer to competitor.
Should AI, so AI is an approach, and certainly it's available to anyone. There is a lot of open source tools to allow people to train AI systems, things like TensorFlow and PyTorch. These are all tools for doing deep learning systems, so that's certainly open. So I'm not sure I understand. I mean, it's like you can say the same thing about software. Is software a competitive advantage? I think yes. Should software be open to everyone? I'd say yes, it is. When a company creates a particular type of software, like an app, let's say, should they make that available to their competitors? You know, there are certainly open source community does that. That's how they survive. But then you wouldn't have any companies because if they had to make their product available, then they wouldn't exist. So I think there's a challenge there.
Thank you, Mike. So thank you for taking time for answering questions and for the interesting lecture. So I would like to thank also the attendees that they stayed for almost 2 hours. And I actually wish everybody a great day. And tomorrow we have the last lecture of the entire series. So bye.
Thank you.